Hello, in this tutorial I'm going to talk about how we can use the simple query syntax here within the standard query interface to perform a query that searches for more than one word. So in previous tutorials I've explained different ways of searching for a single word, and here I'm going to talk about how we can start to search for phrases. So the basic way of searching for a sequence of more than one words is simply to type in that sequence of words with spaces between them, i.e. exactly what you would expect it to be. So, for example, if you want to search for the expression "is there a something," then you could simply type "is there a" with spaces between the words and start query, and it hums away and we get the result. Very, very simple. Now what's actually happening, if I just type that out again, what's actually happening is that whenever there is a space, the things that are separated by spaces, each one is a separate word query. Okay? What that means is that each of these things, each of these sequences that are separated by spaces, can use any of the types of query that you can apply to a single word. So you can use wildcards, you can use tags, you can use lemmas if they're present in your corpus, so on and so forth. So, for instance, let's say if I add "is there a B star," then we are asking for "is there a," and then any word with B followed by any sequence of characters, and there we go, that's what we get. Now, another example would be if we wanted to search for, say, adjectives before a particular noun. Say we wanted to look at the noun thing, and we want to see what kind of adjectives modify the noun thing, then we can search for the tertiary annotation. This corpus has tertiary annotation of using the Oxford simplified tags, which is adjective. Adjective thing, which should give us, yes, it's giving us anything tagged as an adjective followed by the word thing. And you can do any of the things that we've seen in previous tutorials. So one very useful thing that you can do is it allows you to do the type of verb in English which is composed of two words. So, for example, things like go away, come out, go up, or eat up, which is the example I'm using here. Now in that kind of verb, you have one bit, the verb, which can be inflected, so it could be ate or eat or eating, but then the actual prepositional particle or prepositional adverb, whatever you call it, is not a variable. It's not inflected, it's just a single word, and it's always going to be that word. So we use a lemma query for this bit and a word query for this bit. Yes, and you can do searches of this kind of any length, as long as you need it to be, as long as you put spaces between each element. Now there is one proviso here about spaces between each element, which is that all corpora in CQPweb have to be tokenized. And what tokenized means is split apart into words. And usually the splitting apart into words is done just in the same way that you would visually by looking at white space. But in some cases there are differences between just the gaps that you would get in a normal text looking at white space, and the tokenization breaks that are present in CQPweb. One example of this is punctuation. So punctuation marks, such as commas, are always separate to the token, to the word that they are next to. So in a book, for example, you might see something like this. He was happy because something, something, something. And this comma, there is no space between this comma and the preceding word happy. However, in CQPweb, punctuation marks are always tokenized separately. That is, they are treated as separate words. So let's say that you want to find a particular word with a comma after it. So let's say you're looking for a word at the end of a clause. So let's try the word up. If you search for up followed by comma, then you aren't going to find anything. Yes. Oh, sorry, syntax error. I forgot something. Comma is a special character, so we have to escape it. Commas used for alternatives within wildcard searches, as you may remember. Yes, no results. However, if we put in a space, so that we are saying this is up is one word and then the comma is the next token after it, then that should work. Yes, there we are. And you can see the feature that punctuation marks are treated as separate tokens. This is actually visible in the concordance, because you can see that because they're treated as separate tokens by CQPweb, they are presented with a space before and after them. But you have to respect that in the query. A related aspect comes with things which are visually visually part of the same word, part of the same sequence of characters in terms of typographical layout, but which linguistically we consider to be separate words. Again, in CQPweb, these are tokenized separately, and therefore if you want to search for them, you have to search for them specifying that they are separate tokens. So, for example, if we take the word isn't, isn't in English is orthographically a single word, there are no spaces, but linguistically we generally treat it as two words. That means that if you want to search for it, you have to search for it with a space between the is and the n't. If I just search for isn't, there will be no results. On the other hand, if I search for is space n't, there should be lots of results. And indeed, there they are. Now, in English, there is a relatively short range of these things that are tokenized differently from how they appear orthographically. Most of them have to do with verbs, so the nt abbreviation of not, that's tokenized separately, and things like apostrophe L, apostrophe S for is or has, apostrophe D for had. These things are all tokenized separately, and likewise the apostrophe S that is used for the possessive marker is also tokenized separately. So if you want to search for someone's something, then you would have to search like this. Let's say noun apostrophe S, noun. That would find, oh sorry. So this is tag n followed by anything, followed by the word apostrophe S, followed by n, followed by tag n anything. And that should, yeah, okay, so again, you can see that the apostrophe S is being treated as a separate word to the word before it. So those are about the only ones in English. If you're dealing with a language like Chinese, where there are no spaces between words in the flow of a text, then again, that stream of characters will have been separated into word tokens as part of the process of a corpus being installed into CQPweb. So if you're searching for a phrase in a Chinese corpus, then you would have to put spaces between the words. If you just wrote a string of characters, then CQPweb would find nothing. You would have to put in spaces to show the word boundaries that you're looking at. Alright, so that's basic word sequences. Just to summarise, the basic idea is that you put spaces between things that you want to be treated as separate words, and each word chunk of your query can use any of the different types of wildcards and any of the different types of annotations that you can use in a single word query. Another thing that you can sometimes want to do in phrase queries is you want to have optional words. So for example, let us take eat up again. The verb eat up has the property that you can get words in between eat and up. Okay, so for example, I ate my dinner up. That would be one example there. So if we wanted to search for examples of this verb in use, we would have to make allowances for the possibility of words between those two elements. Two characters can be used to do this, and these are plus and star. And this is parallel to, but not the same as, the way that we can use plus and star within words. A star means an optional word. Now, note this means that a star on its own means something different to a star within a word. Okay, so star means an optional word, so either no word at all or just one word. So if I do that search, we will get eat followed by either one word or no word, followed by up, and there we see yes. We have lots of examples of eat up or some form of eat up, but we also have one example there where there is one word between eat and up. Okay. Now we can also use the plus character, and a plus character means any word, right? So any word at all. And again, as with the star, this is similar to but different from what the plus means if you use it inside a word. Now, we saw that there was only one example, so this should find just that one example where there is one word between eat and up. There it is. You can also combine pluses and stars together to get any number of words between the fixed elements. So, for example, what if we want one but possibly two words between? Well, we would do it like that. Eat plus star up. Again, if it's just plus star together, then these are treated as referring to words, not as being wildcards inside a word. So this means eat followed by one token that can be anything and one optional token, so one token or two tokens, followed by up. So we will definitely get one example. Ah yes, so there's our example that we had before with one word between, and then here are some with two words between. Let's try it again, but this time allow for the possibility of three words between. So at least one, and then two optional ones. None with more than two. Okay. So that's how the plus and the star work. That's more or less all the features of the basic phrase searches. What you can do that is more advanced involves using brackets around chunks of your query. Okay, so Let's talk about a different phrasal verb. We talked about eat up. Let's talk about go away. So let's make go into a lemma. What if you wanted to search for away or up or down or through? Well, you could specify that using the notation with brackets and commas, square brackets and commas, but you can also specify it as using normal round brackets and the pipe character, which is this straight line here. Away, what did I say? Away, up, down, through. So what's the difference then between using the square brackets and the commas? Well, between using the square brackets and the commas versus using the brackets and the pipes. Well, the square brackets and the commas always operate within a single word. So, for example, in the tutorial where I introduced the square brackets and the commas, I used the example of realize, which might be spelt with either an S or a Z. So that's happening within a word. By contrast, when we use the round brackets and the pipes, we are always talking about an entire word or a sequence of words. So you can't put, for example, you couldn't put, I think I gave this example before, you couldn't say this man, that woman, because then we've got word breaks inside these brackets. However, this man, that woman, that would be perfectly fine. Okay, so that's the distinction. So here, let's see how this works. Go as a lemma, followed immediately by one of these options, where the options are divided by pipes and the whole thing is surrounded by brackets. Yes, that has got us what we thought it would get us. There it all is. Right. Once we've introduced the brackets, then there is another thing that we can do with them. And that is that we can make them optional or specify a number of them. So an example of this would be, for example, the passive in English. The passive in English consists of some form of the verb to be, followed by some past participle. However, there is the possibility that we can have adverbs between. So, for instance, if I put in adverb, so there is the code for be using the lemma annotation, the secondary annotation, past participle using the tag set in this corpus plus the primary annotation, and adverb using the tertiary annotation, the simplified tag. So let's search for that. Right, so there we are. Mixture of adverbs and the word not, which you might or might not consider to be an adverb depending on your personal taste in grammatical theory, but it's included under that tag. Okay, so that's how we would search for, sorry, let me just go back. That's how we would search for be adverb past participle. But if we put normal brackets around the adverb and we say make it, and we say to the in the query that we want to make it optional, then we can put in a question mark. Right? Again, this is similar to but not the same as the use of question mark within a singular word. Here, when we use question mark, we mean any one character. Here, when we use question mark, what we mean is everything in the brackets that precedes it is optional. Right? We can have 1 or 0 of these things. So question mark means 1 or 0. Okay, so here we are, plenty more examples of be followed by oh yes, here's one of the ones we had before where there is an adverb, but most of these are examples where there is no adverb. But you can see that we've got here an optional adverb in the query. Alright, what about two adverbs? So you could for example say, he has not really been visited. Not really been, has not really been, no, that's sorry, I'm getting muddled. That's perfect, not passive. How about he is not really visited, or he is not really wanted, something like that. Is not really wanted. We would want two adverbs here. Okay, well, if we want the possibility of more than one thing, the question mark only allows for the possibility of one or zero. If we want to allow zero or more, we use a star. And yes, this is a third distinct use of the star. Sorry about that. It's just the nature of the query language. So when it comes after a bracket, what the star means is zero or more examples of whatever is in the bracket. We start the query. Right, so we've got, again, lots of examples of 0. There's an example of 1. Can I find an example of 2? I'm not going to go too far through the query looking for an example of 2. Okay, I can't find one quickly. However, if I go back, what we can actually do is instead of star, we can use plus there. And plus means one or more. Okay, and again, slightly different use of the plus symbol to how we've seen it being used before. When it comes after brackets, what it means is one or more of whatever is in the brackets. So this is be followed by one or more adverbs followed by a past participle. Right, okay. Aha, so now we can find some with 2. There's one with 2. Can I find one with 3? Probably not. There's another with 2. So there are quite a few with 2 adverbs, but there are not so many with 3 adverbs, at least not so far as we can see, although there are 10,000 matches, so it could take quite a long time to make certain. Sorry, again, let me go backwards so I don't lose the query. So, we have seen question mark, star, and plus. Question mark, 0 or 1 of whatever is in the brackets before. Star, any number of what's in the brackets before, 0 or more. And plus 1 or more of whatever is in the brackets before. Okay? We can also specify a particular number. Okay? So what we do for that is that we put after the brackets here, we put braces. And in this context, what braces do is it allows us to specify a pair of particular numbers, the minimum and the maximum that we want. So let's search for, not 2, let's search for at least 3 and at most 5 adverbs and see what we get. Probably not many examples, if any. Oh, no, quite a lot. 169. All too often, no longer directly, this more eagerly, that actually looks like a tagging error, at least in part driven, these are multi-word adverbs that consist of preposition-noun combinations functioning as adverbs, adverbs overall. Almost entirely funded, generally very indifferently. Okay, so these kinds of things, we do have quite long series of adverbs there. Let me go back. So, question mark, 0 or 1, star, 0 or more, plus one or more, and numbers in braces between this many and this many, between this and this. Now, the thing that comes within the brackets can include alternatives, right? It doesn't have to contain just one word. It can contain a sequence of words, or it can contain alternatives. So let's look at an example using alternatives. Let's say that we want to search for the noun, and let's go for the noun thing again. And let's say that before the noun we want all sequences of adverbs and adjectives. Okay, so we want either an adjective or an adverb. Missed out a brace there. And we want the longest string possible, so let's say plus. We want at least one and as many as are there. So that should catch all the things that are pre-modifying thing, even if they are complex adjective phrases that consist of adjectives and adverbs. So you'll notice incidentally that the more complex the queries, the longer it takes them to run. And there we are. Adjectives, determiners and adverbs, because in the simple tag set, the Oxford simple tag set, determiners go in with adjectives. So we've got long strings of modifiers before the word thing. The last thing to mention when talking about phrase searches is that you can also use what are called XML elements in a phrase search. What are XML elements? Well, corpora are not always just a flat sequence of tokens. Sometimes they are divided into units, or they have extra information included using XML tags that are bounded in angle brackets. And if you've been working on corpora for any length of time, then you will run into these things. In CQPweb, these divisions, or these things that are not words, such as paragraph breaks or omitted elements or places where pictures were in the original text, or in a spoken corpus you might have sounds, noises, vocalizations. These things can be stored in a CQPweb corpus, but they are not typically visible. But you can search on them. So this particular corpus that I'm working with, which is the Brown family I've been doing this demo on, it has sentence tags in it, and the sentence tags are labelled as S in angle brackets. What that means is that you can say you can use the S element as part of your search. So let us say that we want a particular word at the start of a sentence. We can search for it after this S as an XML element. So let's take the word however, for instance. This will search for however just at the start of a sentence. And there we go. You can see that indeed, yes, all of these examples of however are actually at the start of a sentence. Okay. The sentence tags are, like most things in a corpus, only as reliable as the software that inserted them. If you're working with a spoken corpus, then you might have utterance tags. Often U is used for that, so that would be U, however, at the start of a spoken utterance. You would have to check exactly on your corpus setup to find out how exactly utterances are encoded, but using U is a fairly common one. And whatever other XML is present, you can also search for it. But remember, if I go forward to that concordance, the XML elements that you've searched for do not actually show up, so only the words show up. The XML patterns restrict your search, but they do not appear in the concordance. There is a slight proviso to that, is that some XML elements can appear sometimes if your corpus has been set up to allow that, but most of the time they will not. Okay, That's more or less it when it comes to phrase queries in the simple query language. Again, this link here leads you to a document that summarizes most of what I've said about the query language, both in this tutorial and in others. Thanks for listening.